Nvidia has overtaken Microsoft and Apple to become the world's most valuable company.
As a chip-making giant, Nvidia broke the $3 trillion valuation mark.
Jensen Huang announces a major partnership between Nvidia and Dell, transforming factories with advanced technology. This collaboration allows any company to start large-scale production quickly, making cutting-edge manufacturing widely accessible. But as these AI-powered factories take shape, one question looms large. Will this new AI factory replace human roles in industry? Join us as we explore the future of intelligent manufacturing. The Dell-Nvidia collaboration. Michael Dell has made this complex setup much simpler, just like Dell did with personal computers back in the day. They're using the same method for these high-tech factories. Any company can now go to Intel with specific needs or designs and quickly start large-scale production. This is a big step forward, making it possible to create intelligent systems on a large scale, which opens up new possibilities for technology and innovation. But that's not all. This move also means that businesses of all sizes can access cutting-edge technology without needing a huge budget or technical know-how. By simplifying the setup, Dell and Nvidia are making advanced manufacturing more accessible than ever before. This could change the way industries operate, making them more efficient and innovative. And here's something even more exciting. This collaboration isn't just about making things easier, it's about pushing the boundaries of what's possible. By combining Dell's expertise in hardware with Nvidia's prowess in graphics and AI, they're creating a powerhouse that can drive significant advancements in various fields. Whether it's in manufacturing, healthcare, or any other sector, this partnership promises to bring about substantial improvements. But the real game changer is how this partnership is setting new standards for the industry. By integrating the best of both worlds, Dell's robust hardware solutions and Nvidia's cutting-edge AI technology, companies can now achieve unprecedented levels of performance and efficiency. This collaboration is not just a step forward, it's a giant leap that redefines the future of intelligent manufacturing and innovation. Nvidia's total cost of ownership is so low that even if competitors offered their chips for free, it still wouldn't be cheaper. Over the past decade, Nvidia has made computing and deep learning 1,000,000 times more affordable. This dramatic decrease in cost allows for extraordinary uses of computing power. For instance, imagine utilizing this power to access all human knowledge online, capturing every bit of information from the internet, and letting a computer analyze and understand all that data. It's a bold idea, letting a single computer process and understand all the internet's data. But this is possible because the cost of computing is getting close to zero. With this breakthrough, Nvidia has created a new way to develop software that even beginners in artificial intelligence can appreciate. Nvidia has learned how to make computers not just see patterns, but also understand the meanings behind vast amounts of digital data. Think about gene sequencing. It turns biological genes into digital data. Thanks to large language models, we can now understand what these genes do. We can figure out the function of a cell, just like interpreting a page of text. This is revolutionary because it turns complex biological data into a story that a computer can read and summarize. But this isn't the end of the story. Nvidia is about to enable continuous learning, where training AI and applying what it learns becomes seamless and constant. This ongoing cycle of learning and application will be just like human learning, continuous and integrated with real-world data, both actual and generated by the computer itself. In hardware, Nvidia's top GPU, the H100, will soon be followed by the H200, with plans to improve this technology every year. By 2029, Nvidia might introduce the H700, pushing capabilities even further. These chips aren't small. One chip weighs 70 pounds and includes thousands of parts, yet it can replace entire data centers. The cost might seem high at $250,000 per chip, but when you consider the savings from data center operations, the investment is worth it. This single chip greatly reduces operational costs and boosts computational efficiency to levels we couldn't imagine before. But that's not all. As NVIDIA keeps driving the cost of computing down to nearly zero, the possibilities for its use grow. It's like how lower transportation costs make travel more accessible. Just as cheaper travel encourages more trips, lower computing costs will encourage more complex computing tasks. This shift will change how we solve problems and innovate, making projects that seemed impossible before now feasible and affordable. This isn't just about technical capabilities. It's about changing how we interact with digital information. The potential to revolutionize industries like drug discovery is huge. AI can help us understand the complex data and interactions within biology. This isn't just about reading a PDF, it's about understanding the essence of the research, grasping the details of scientific breakthroughs as if talking directly to the researchers. This deep understanding of data's meaning, enabled by advanced computing, is set to be one of the most significant advancements of our time. But the true potential of this innovation goes beyond immediate applications. Jensen Huang envisions a future where AI and advanced computing reshape our daily lives, making technology more intuitive and integrated. This ongoing development promises not just incremental improvements, but a fundamental shift in how we perceive and utilize technology in every aspect of our lives. Let's see how NVIDIA started with gaming and grew into much more. NVIDIA's evolution into general-purpose GPU powerhouse. Back in the early 2000s, NVIDIA was mainly focused on making hardware for real-time computer graphics, especially for gaming. They used graphics cards to help the main computer processor, the CPU, handle the heavy work. But as GPUs got better, engineers saw they could be used for more than just making games look good. They realized that this hardware could do more than just render graphics, leading NVIDIA to shift towards the idea of the general-purpose GPU. This meant GPUs were now not just for graphics, but could be used for many tasks like cryptography, data analysis, scientific simulations, and deep learning. But this change wasn't easy. At first, if you wanted to use a GPU for something other than graphics, you had to translate your scientific code into something the GPU could understand. It was like trying to make a painter do complex scientific experiments, a tough and confusing job. In 2007, NVIDIA made a big leap with CUDA, Compute Unified Device Architecture, which made it much easier for developers to program GPUs. CUDA let programmers write code for GPUs in a way that was more familiar to them, opening up many new possibilities. This was crucial because it made the complex language of GPUs more accessible to general programming. But this wasn't the whole story. The evolution of CUDA is closely linked with the rise of deep learning. Neural networks process information layer by layer, and since neurons in the same layer don't rely on each other, each neuron's calculations can happen independently and at the same time. This parallel processing was perfect for GPUs, which could handle many tasks at once, speeding up computations. Additionally, the work involved in computer graphics, like multiplying matrices and vectors, is very similar to the operations needed in neural networks. By 2010, GPUs had become well-suited for general tasks and were particularly effective for training algorithms used in artificial intelligence, especially neural networks. But that's not all. In 2012, a team including Jeffrey Hinton, Ilya Sutskever, and Alex Krzyzewski used multiple GPUs to train a neural network called AlexNet. They entered it into an image recognition competition where many other labs not using deep learning presented their solutions. AlexNet, powered by GPU-accelerated training, outperformed all the others, showing the immense power of artificial neural networks. This event is often seen as the start of the deep learning revolution. The key breakthrough with AlexNet was its use of GPUs to speed up training, allowing the team to train larger networks with more data much faster than before. This highlighted the critical role of GPUs in advancing deep learning and marked a pivotal moment where the potential of neural networks was widely recognized. From that point on, the rest, as they say, is history. The combination of deep learning and GPU technology sparked a tech revolution that continues to grow and influence many fields. leading to new eras of innovation and discovery in artificial intelligence. But this wasn't the whole story. Jensen Huang introduced the law of Jensen a few years ago, similar to Moore's law, which predicted that the number of transistors on a chip would double every 2 years. However, the law of Jensen focuses on GPUs and predicts that their performance would double every year. This is interesting because while Moore's law faces physical limits, GPUs continue to improve through new optimization techniques and better chip designs that take advantage of parallel computing, especially in AI. In 2019, NVIDIA's progress was astounding. 5 years earlier, servers with K80 GPUs took 600 hours to train a model like ResNet 50. By 2019, this task took just 2 hours, a 30-fold improvement in 5 years, effectively doubling performance each year. But this was in 2019, and the trend has continued. Looking at the progress from P1 GPUs to V100, then A100, and recently the H100, the performance of these chips has increased 1,000-fold in a decade. This massive improvement meets the growing demand for more computing power in AI training and inference. But this wasn't the worst part. The last 2 years have seen even more significant advancements with the rise of generative AI and large language models. For example, it was estimated that training GPT-4 took around 25,000 NVIDIA, a 100 chips over 90 to 100 days. Using the newer H100 chips, the same training would need only about 8,192 H100s, taking half the time. This reduction in time, cost, and number of chips is crucial and explains why, in 2023, many companies in Silicon Valley are eager to get their hands on NVIDIA chips. Access to A100 and H100 GPUs became the new currency. There was talk of rich GPUs, big tech companies with vast computing resources, and poor GPUs, startups with limited access. It's troubling to see this gap growing. For instance, Meta announced it would have 350,000 H100 GPUs by the end of 2024, which combined with their infrastructure would give them the power equivalent to 600,000 H100s. Meanwhile, consumer hardware is also adapting to this new AI era. Graphics cards for consumers have focused on increasing tensor cores and memory on these cores. Tensor cores are specialized for fast matrix calculations, crucial for speeding up deep learning tasks. Memory has also grown steadily over the years. But the real challenge isn't over. The future promises more open source models that are even more capable. People will want to run these models on their computers, requiring powerful graphics cards. An example is DLSS, Deep Learning Supersampling, which uses AI to improve game visuals while reducing the graphics workload. This allows the GPU to focus on more intensive processes. This is just one example of how AI is transforming not just science and industry, but also our daily interactions with technology, heralding a new era where AI performance will be essential. Next, discover how NVIDIA's tech is changing computing and AI. NVIDIA's leap into accelerated AI. At the heart of what Jensen Huang is discussing today are two powerful technologies: accelerated computing and artificial intelligence working within the Omniverse. These technologies are set to change the entire computer industry, which is now over 60 years old. Much of the basic technology used today was thought up in 1964, right after the IBM System 360 introduced concepts like the central processing unit, CPU, multitasking, and the separation of hardware and software. These innovations paved the way for making computing accessible to everyone, starting with personal computers and later with mobile devices like the iPhone in 2007. This progression has led to a time where connectivity and mobile cloud operations are everywhere. Over the last 60 years, computing has seen a few major changes, but now it is on the edge of another big shift. The CPU, which has been the backbone of the industry, is slowing down in performance improvements, while the need for more computational power keeps growing. This mismatch is causing computation inflation, where the cost of computing is going up as the power usage of data centers around the world increases. To tackle these challenges, NVIDIA has been leading the way in accelerated computing for almost 20 years. The idea is simple but groundbreaking. move and speed up tasks that specialized processors like GPUs can do better than CPUs. The results have been amazing, showing that every possible application should be accelerated, especially those in data centers. For example, tasks that would normally take 100 units of time can be sped up to just 1 unit of time using this technology. The benefits are huge: a 100x speed increase in performance while only using 3 times more power and increasing costs by about 50%. In practical terms, adding a $500 GPU to a $1,000 PC can greatly boost its performance, just as adding significant GPU resources to a data center can turn it into an AI powerhouse. But this isn't the only exciting part. This acceleration applies not just to traditional computing tasks, but also to more complex algorithms used in deep learning, computer graphics, physics simulations, and more. These tasks are perfect for parallel processing, which GPUs excel at. To support this, NVIDIA developed CUDA, a platform that enhances CPUs with GPU acceleration, handling tasks from AI and physics to telecommunications, and even quantum computing simulations. One of the most exciting uses of this technology is in creating digital twins, like NVIDIA's Project Earth 2, which aims to simulate the Earth to predict and prepare for climate impacts. This project and others like it use the immense power of accelerated computing to do tasks that were previously unimaginable. But this isn't the whole story. Looking ahead, the potential for accelerated computing continues to grow. Every data center will likely use this technology, cutting down the time and cost needed to process large amounts of data. This shift is not only about making things more efficient, but also about achieving incredible computational capabilities that will change what can be done with technology. As we move further into the era of AI, especially generative AI, the impact of these technologies becomes even greater. Generative AI, which can create content from text to images and more, is starting to change how people interact with machines. It's becoming less about telling a computer what to do and more about interacting with a system that understands and anticipates needs. But this isn't the last transformation. In this period of rapid change, NVIDIA's ongoing innovation in accelerated computing and AI is not just boosting computational efficiency, but also setting the stage for the next wave of technological advancements. This isn't just a shift, it's a complete overhaul of how technology is thought about and used. In the world of technology, a big change is happening. It started with a supercomputer and has now become something much bigger, a data center dedicated to AI. Jensen Huang explains that this isn't just any data center, it's an AI factory, and its main product is something called tokens. To understand NVIDIA's vision for the future, it's important to know why this AI factory is so special. It's not making regular products, but creating a new, very valuable commodity: tokens. These tokens are to the digital economy what electricity was to the industrial age. Just like Nikola Tesla's invention of the AC generator changed the world by generating electricity, NVIDIA's AI generator is making tokens. Both inventions opened up huge market opportunities, marking a new industrial revolution. Every industry can use these tokens, making them very useful and applicable in many different fields. Imagine an AI factory working like a traditional factory, but producing digital outputs that can be scaled up and repeated endlessly. This approach is quickly changing the IT industry, which was traditionally valued at $3 trillion, and is now looking at a market that could be worth $100 trillion. This shift shows a move from using computers mainly for data storage and processing to using them to generate intelligence that can be applied across all industries. But this wasn't the only big shift. This new way of creating intelligence through computers represents a big change from the past and promises to set new industry standards. Accelerated computing, which evolved into AI and then into generative AI, is now leading an industrial revolution. The impact on the industry is huge, with the potential to create a new commodity, tokens, that can be customized for many different uses. For the first time in 60 years, every layer of computing, from CPUs to GPUs, is being redesigned. The change from general-purpose computing to accelerated GPU computing has redefined how computers handle information. The old model was about retrieving data, You interact with your phone or computer, and it retrieves pre-stored data for you. But the future is about computers generating much of the content dynamically, making data retrieval faster and more relevant. This isn't just about saving energy or speeding up processes. It's about creating data that understands and adapts to the user. Instead of asking for a file or information, you'll ask your computer for an answer, and it will generate the best response based on a deep understanding of the context and the user. But the story doesn't end here. Enter NVIDIA's NIMs, NVIDIA Inference Microservices, the building blocks of this new AI factory. NIMs are pre-trained AI models that can run anywhere, cloud or on-site, giving businesses the power of AI without needing to build the complex infrastructure themselves. These NIMs can handle many tasks, from language processing to complex data analysis, and are designed to work in parallel, spreading tasks across multiple GPUs. This parallelism makes sure the AI factory's output, a key measure of its success, is maximized. Data centers are becoming more like factories, with every part of their operation, from start time to usage rates, carefully optimized to improve performance and reduce costs. NVIDIA has made this complex integration of hardware and software simpler by offering AI in a box. This package includes everything needed: CUDA, CNMIM, TensorRT, Triton for inference services, and more, within a cloud-native container that can scale automatically. This setup ensures companies can deploy AI quickly and efficiently, with standardized APIs that make these services easy to use for anyone with basic technical skills. But this wasn't the last exciting development. As digital interaction gets more advanced, NVIDIA is also leading the way in creating digital humans. These AI-driven entities can act as customer service agents, brand ambassadors, or virtual companions, providing services that are effective, engaging, and empathetic. These digital humans are built on lifelike models that can converse, understand, and interact in ways that make them seem almost human. This technology uses advanced graphics and AI to create appearances and behaviors so natural they cross the uncanny valley, the point where a robot or avatar looks almost, but not quite, like a real person. As we stand on the brink of this new era, the potential uses for AI are endless. From transforming customer service to revolutionizing how we interact with technology, NVIDIA's journey with its AI factory and digital humans is not just about advancing technology, but about creating a more interactive, responsive, and understanding digital world. Now take a closer look at how NVIDIA's new tech is upgrading data centers. NVIDIA's Blackwell and the future of AI supercomputing. NVIDIA is moving forward with powerful hardware designed to boost AI development and use. Jensen Huang explains that this next step in technology focuses on making data centers even better. These centers have grown a lot in both size and capability. At first, the move from DGX systems to large AI supercomputers helped us train models like transformers on huge data sets, which used to need a lot of human supervision. But with transformers, the need for human oversight has lessened. These models can now learn on their own, finding patterns in massive amounts of images, videos, and text. But this isn't the end of the story. The next big challenge for AI is to ground these systems in the physical laws of our world. Today's AIs don't understand physics well, which limits their ability to create realistic images, videos, and 3D graphics, or model physical events accurately. To fix this, NVIDIA is looking at several paths: better video analysis, creating data from simulations, and intercomputer learning, similar to how AlphaGo improved through self-play. This is like how human skills develop. With continuous practice and learning, AI can get much better than its initial programming. NVIDIA's new generation, called Blackwell, is designed to tackle these challenges. Blackwell is not just a new GPU, it's a huge step forward. It has two of the largest chips NVIDIA has ever made, connected by a super-fast link that allows very quick data transfers. This setup lets us simulate and understand complex physical systems in ways we couldn't before. But this wasn't the only exciting part. The Blackwell architecture has a new CPU setup that helps the machine save progress and restart quickly, which is crucial for long AI training sessions. It also improves memory management, essential for AI tasks that need deep understanding during interactions. like having sophisticated conversations that feel natural. Central to Blackwell's design is the second-generation transformer engine. This engine adapts the precision of computations to make processing more efficient across different tasks. Security features are also built in to protect AI data from unauthorized access or tampering. NVIDIA didn't stop there. The fifth-generation NVL link connects GPUs at super-fast speeds, allowing networks of these processors to work together. This makes the kind of rapid, complex computations that modern AI needs possible, pushing the boundaries of what AI can do. But this wasn't the last innovation. The new decompression engine speeds up the retrieval of stored data, crucial given the vast amounts of information AI systems need to access and process. This feature increases speed by 20 times compared to current technologies, reducing the time systems spend waiting for data. In short, Blackwell is not just a component, it's the base of a new era of supercomputing that will help AIs learn and work within the physical rules of our world. It's designed for the growing needs of generative AI, which requires a lot of computational power to create detailed simulations and real-time interactions in virtual environments. As NVIDIA keeps pushing forward, the Blackwell platform and its successors are set to change the AI computing landscape. Each new version brings us closer to a world where AI can smoothly integrate with the physical laws that govern our reality, opening new possibilities for scientific discovery, entertainment, and daily interactions. This isn't just about technology, it's a gateway to the future of how we understand and interact with the world around us. Moving forward, see how NVIDIA is making robots understand the real world. The advent of physical AI. The next wave of AI is about creating machines that truly understand the physical world, a concept called physical AI. Jensen Huang explains that this advanced form of artificial intelligence isn't just about processing data. It's about building machines that can navigate our world, understand its laws, and interact with the environment and humans in intuitive ways. Imagine robots that don't just perform tasks, but understand those tasks in the context of a physical world governed by the rules of physics. These AI systems need to excel not only in understanding complex instructions and processing information, but also in physical interaction. They should perform tasks with the precision and adaptability needed in complex environments. When people think of robotics, they often imagine humanoid robots, but the future includes much more. Soon, almost everything in factories could be robotic, with AI directing robots to manufacture sophisticated products. But this isn't the end of the story. To reach this future, significant breakthroughs are needed. Technologies that allow robots to learn from physical interactions within simulated environments are key. Using platforms like NVIDIA's Omniverse, robots can train in highly detailed, physically accurate simulations. This way, they learn tasks through trial and error without the risks of real-world training. Omniverse serves as a kind of robotic gym where AI systems practice and refine various skills, from basic movement and navigation to complex tasks like handling delicate objects. This simulated training is crucial because it bridges the gap between theoretical learning and real-world application, making it easier for robots to adapt their learned skills to everyday tasks. But this isn't all that's needed. Building these sophisticated AIs requires incredible computing power. NVIDIA's AI supercomputers train the models. The Jetson Orin and the next-generation Jetson Thor robotic supercomputers run these models. And the NVIDIA Omniverse provides the environment where these AIs can evolve and refine their abilities. For developers and companies, NVIDIA offers a complete set of technologies, from the platforms themselves to acceleration libraries and pre-trained AI models. This setup ensures that whether a company is building robotic factories, autonomous vehicles, or humanoid robots, they have the necessary tools and frameworks at their disposal. But this wasn't the worst part. The implications for industries are huge. In the near future, factories and warehouses could operate fully autonomously, with robots building robots and AI systems continuously learning and adapting. Each type of robotic system, from those handling materials to those interacting in human-like ways, will have customized platforms designed to meet specific needs. For instance, in robotic warehouses, NVIDIA's technology integrates seamlessly with existing systems, providing SDKs and APIs that connect into the broader software and industrial automation ecosystems. These robotic systems are not standalone. They're part of a complex network of technologies, including everything from edge AI devices to industrial PLCs, programmable logic controllers. In more advanced applications, such as those developed by companies like Foxconn, entire factories are being designed as digital twins within Omniverse. These digital twins simulate the factory's operations, allowing for optimization and planning before physical changes are made, saving costs and improving efficiency. But this wasn't the end. The move towards robotic systems that can handle manufacturing, warehousing, and even personal interactions like customer service or healthcare is not just theoretical, it's happening now. These systems are being trained to understand and interact in human ways, learning from vast amounts of data how to navigate and operate in our world. This shift toward intelligent, autonomous robots that can learn, adapt, and understand the physical laws of our environment is transforming every sector of industry. It represents not just a step forward in AI, but a new era of robotics, where the boundaries between the digital and physical worlds blur, leading to unprecedented possibilities in how we live and work. Do you think AI will eventually replace human jobs in industries? Leave a comment with your thoughts, and don't forget to subscribe for more.